Hi everyone. People were interested in what I was doing all this time during my PhD, so I'll give you a quick shot into my thesis. So I was working on these really special group of minerals, these iron oxyhydroxide green rusts, and how they were relevant to early Earth chemistry, emergence of life, and possibly abating greenhouse gas emissions. So to take you back, modern Earth, it's a very nice place to live, has a bunch of life, has a very nice atmosphere with a lot of oxygen and low amounts of CO2 and methane. But on the ancient Earth, some like 4 billion to 3 billion years ago, much different place. Lots of methane, lots of CO2 back then, limited continental exposure, quite cold, and the oceans were filled with iron, dissolved iron, and there was no life. So how did life come to be when there was no life to begin with? Well, we think there's something to do with all this ancient iron that was dissolved in the oceans that streamed out of the inner Earth from the hydrothermal vents and plate tectonics and serpentization processes that shot out these huge plumes and chimneys of iron and other elements and precipitated as minerals. One of these mineral species that would have precipitated was green rust, these iron oxyhydroxide mixed valence materials, which have very interesting properties. A little technical difficulties there, but if you look under the microscope here, you could see very green mineral species present. You could see some natural version called fusarite, which you could find in anoxic soils and muds in the north of France. Actually was discovered. But when you look at SEM, you see these little hexagons, and that's where the magic is. That's where green rust is, and it's these octahedrally coordinated mineral species with a sandwich-like layer. That's the LDH component, these layer double hydroxides, and they can sandwich in different anionic species. So green rust can do a lot of different things, like substitute different metals, and really it's very interesting for its electron transfer properties. It's very good at reducing environmental contaminants like metals, organic compounds, and dangerous materials. So I'll talk a little bit more about how that relates to origin of life in the next video. Hello. 你好，上好书。
你好。